while he's doing,
Okay, thank you.
Eric, can we get the answer from Andrew about what the result was of increasing the?
Yeah, I'm looking for that too, but I have a question about clearing a fault with the earth rod. It's my understanding or misunderstanding that the earth rod or ground rod is for lightning protection and not for fault clearing, because there's so much resistance on the rod that it couldn't clear a short or a fault on a circuit. Can you advise me?
Only
on
if it's
that?
connected to the neutral bond.
What?
Only if it's connected to a neutral bond.
Right. So it could also go back to the utility. Is that what you're saying?
That's the only way it works to
Okay.
clear a fault. So you're getting a wire path that goes back to the neutral, which causes the breaker to sense that it's over current.
Right. Okay.
But it always is, Bill, isn't it? Always connected to the neutral?
Yeah. The question was, how does a ground rod clear a fault? It doesn't. It does it in conjunction with the neutral bond.
Right.
Yeah.
Okay.
Okay.
Does that make sense?
So Andrew, can you just briefly summarize what change you noted with your bed mapping? You're talking about electric field?
It's primarily a magnetic field issue, and I go into this later in my presentation about if you are going to increase the grounding current, the current through the grounding electroconductor, what's the consequence of doing that? If there is another path in the house for current to come through the home, current will increase. If there is not another path through the house, current will decrease. So this gets into my presentation. I'm happy to cover it later. I put a link in there if anybody wants to see the bed map results.
I'm projecting it now. I'm sharing.
Okay, so that's magnetic field, but not electric field.
Electric field is a separate topic, and I'll get into that later.
Okay.
But look at the delta in the magnetic field.
14 milligauss to 0?
Well, this is actually on the left is magnetic field, and on the right is electric field. You have to actually purchase it to find all the results in this. You're going way down the rabbit hole on this. Anybody wants really quick answers, we have to wait.
That's fine.
We'll get into this. But Andrew, you're telling me the difference is dramatic.
There is a significant result difference when you help the neutral take stuff out of the home, because the neutral is bad.
It's overloaded. It could be good, but it's overloaded.
Right.
Would that also be true?
Yes.
Like the utility primary is overloaded.
So Andrew, when to follow up on Eric's point, when you say the neutral is bad, you don't mean a broken neutral or loose neutral. You mean just an overloaded neutral. Is that right?
That's correct. There is current coming from the neutral into the home.
Well, going back to the utility.
However you want to see it, it's AC current. It's moving two ways. It's creating a circuit. It is bringing current into the home.
Yeah, that's what I understand. There's so much pressure on the utility primary system that the neutral current is looking for any and all pathways back to the substation, even that's through your grounding system and then through the earth.
Because the neutrals were undersized in the grid.
Yeah.
Oh yeah, overloaded.
Got
Too much high frequency current.
Is it because we have more devices plugged in homes than we did decades ago, or is it because of more DE, or both?
Yeah, both.
Yeah, nonlinear loads basically on the neutral.
So if we have more DE producing devices in people's homes, creating these nonlinear loads, does that also produce more frank current that we can measure with an amp clamp, and therefore more magnetic fields that we can measure with a Gauss meter?
Yes.
All right, we're getting hot in the weeds here, guys. So I'm going to get us back on track if you don't mind.
Sure.
That's going to be fascinating to get into.
So this is our agenda from yesterday. Can you see that?
Yeah, where are those posted?
They're on my website, and I sent them out in the file structure that was sent out the day before yesterday.
Okay.
So it's all there. The PDF. So anyway, we got through the ground antenna concept a little bit in the lab exercise. I have some photos. Did you send those photos?
I think they just sent, and
Okay.
I got one more, it was taking really long, so I hooked
All right, let me look here.
them. I got some more, but I think those are the better ones. It was hard to take photos of the tiny wire.
Yeah, it is hard.
So.
All right, so what we did this morning is we went out and kind of emulate the ground antenna. So we connected up the pipes to the ground that's outside, and we also went to the screws on the ground wire, on the ground antenna, and then strung out some wires on the ground antenna just to see, you know, show you what it looks like, okay, on the dirt. And we took some photos. So as soon as I get those photos, we'll put them up for everybody and send it out. Okay. So any questions from yesterday's exercises?
Yes,
Go
Bill.
ahead.
Jeff Zender. I have a question about the placement of the rods when you need more than one ground rod, but you don't have space to lay them horizontally. Can you, and it's cumbersome, or can you put these rods next to each other, or maybe 10 feet apart, but vertically down into the earth, connect them to each other? Is that going to be just as effective as pounding them one on top of the other till it's one great big long rod?
Yes, yeah, it's just as effective.
Just, okay. So
Okay.
I can put, how much distance do you need to keep them from each other, or can you put them right next to each other?
So we talked yesterday about the resistance bridge. And give me a second and I'll demonstrate this to everybody. Hold on a minute.
Okay.
Code says a minimum of 6 feet apart. When they're closer than 6 feet, the fields overlap and diminish the efficacy of the two grounding electrodes.
Thank you.
Hey, Andrew, can you clarify that? I feel like yesterday where we ended was, test the resistance of one ground rod, and if you need more, add it, but ideally you just have one.
Right.
Okay, I thought you just said the opposite.
No, if you're going to add a second, the distance needs to be a minimum of 6 feet away. Any closer than 6 feet, the efficacy of the second grounding electrode is reduced.
Got it.
Yeah, Andrew, that's, according to code, which we find out is pretty minimal. When we get, and they're not considering the high frequency trash that's on the electrodes these days. So what's really Bill, what would be more of an optimal distance to separate a second ground rod?
All right, so in my field testing, okay, I have found that if somebody's got their, in the room, someone has their microphone on, please turn the microphone off. Okay, sorry. I should this stuff. So in my field experience, here's what I do. Let's say we have one ground rod in the dirt. Let me see if there's a whiteboard I can use. Hold on a minute. Forgot how to get to the whiteboard.
You have to go to share screen.
What's
And
that?
then you will see it.
Go to what?
Share screen.
Share screen. Okay, give me that.
Right now, you're sharing already your screen. So you have to get out of
Okay, I
it.
can go into share screen. Is there a there's a whiteboard. Okay, fine. Very good. Thank you. So we use the whiteboard. Can everybody see that?
Yep.
All right, so I'm going to do a little drawing here. I think I can do a drawing. Yeah, I think so. So I do a circle. Here's my first ground rod, okay? So this is running to the house. There's a wire running to the house, okay? And say that wire from there, that wire there I measure, and I got 100 ohms. Okay, just for this exercise.
Yeah.
Okay, now I say, well, that's not enough. I need lower than 100 ohms. So if you've ever done any testing with ganging together resistors, okay, and so I don't think you can see it, but I will demonstrate it. So I will put in the field another rod here and another rod next to it, separated by 2 feet. Okay,
2 feet.
2 feet. And then this wire is connected to this wire, and this rod is connected to that wire. Okay, so it's a parallel path. Now, the rod is 8 feet deep. Okay, so this is the top of the resistance bridge. It's like twisting together the resistors, okay, at the top. When you put in the dirt, you're using the dirt as the other end of the resistor bridge. So this rod is going down in the dirt, right? This one's going down in the dirt. This one's going down in the dirt. See that? And while you don't realize it, the ground is conductive. And so now, because it's conductive, I now am making a connection at this end. See that?
Yeah, but why are they only 2 feet apart?
Because you're trying to increase the effectiveness of the resistance, reducing the resistance of the path of getting rid of the DE or whatever. So
Okay, so
that's why
it
it's
works
2 feet.
better.
If it's 6 feet apart, there's too much dirt between the rods to make a connection at the bottom of the hole.
All right, so what would the measurement be now, theoretically?
Let's just say this is the same, right? So this is 100 ohms here. So
Yeah,
when you do this, it's probably going
Yeah.
to make it down to 50.
okay,
Just presume everything's the same, okay?
right.
So that's
So
not
how
good
would you-
enough, right?
How would you do that when you're pounding them vertically into the earth to get the?
The dirt becomes the wire in the bottom of the hole.
Why on the bottom, Bill, and not through the whole length of these
Well,
rods?
it is the whole length. You're correct. I just want to, for the demonstration of this class, I'm just trying to show.
Okay, all right.
Because when you go back to looking at joining resistors together, you come up with that, right? You've already twisted 2 resistors together, 200 ohm resistors together, and you get 50 ohms. You measure both ends of the 2 wires twisted together, and you get 50 ohms, not 100 ohms. Using 2 100 ohm resistors, right?
Hey, Bill, wasn't there a section yesterday where we talked about not wanting more than 1 ground rod because the current paths could flip back and forth between them?
That's why these are only 2 feet apart.
To minimize that.
Absolutely.
Okay.
And you'll notice it's in parallel, not in series. Because what was shown before was that there's a wire running from the house to a rod, and then they run a wire from here to another rod. This is a series connection, not a parallel connection.
Great. Good clarification. Thanks.
Okay, and that's kind of what causes the cycling, because it's in series. Anybody that has any electronic circuit board manufacturing experience will tell you never put daisy chain of a ground path on your circuit board. Never.
Bill, I'm a
Yes.
little confused now. Can you just, why are we doing the 3 that you just, the
Okay.
diagram you made versus the one on the left?
Because the concept of a resistance bridge is that you don't work in pairs, you work in odds, right? So this is the first rod, right? And we had 100 ohms here,
Yeah.
okay? Now I want to reduce the resistance. So in order to reduce resistance, I keep the first rod in place and I add 2 more rods, okay? And so these 2 rods are basically creating a secondary resistor, so to speak. that's because of the two combined. This is 100 ohms here, this is 100 ohms here, and 100 ohms here. I think that at the end of the day, we'll get somewhere around between 33 and 50 ohms in that range. Now on the rod going on the wire going to the panel. Okay.
And on the example on the left,
That is the series connection that's in the diagram that we saw yesterday in the Mike Holt book, you know, where you have the two rods 6 feet apart. And in my testing, I find that if the conductivity is inconsistent between one rod and the other rod, the grounding system will cycle up and down, up and down, up and down, up and down.
okay, so you're not recommending that. You're
I do not
recommending the one with the
recommend it.
three.
Now, if the electrician, you know, there's, you know, when they got this rule, you know, so I'm going to put 2 ground rods in. I don't care what you say. Okay, fine. Thank you very much. Go back over, cut the wire. Because it's going to cause more problems than it. If you got somebody that's really sensitive, you do not want to put a ground circuit in series. Okay? Because if there's any cycling going on here, it's going to balance itself out amongst the 3 rods. Okay.
Bill, what you're saying is you, on the image on the left, you get a yo-yo effect?
Yes.
Is that right?
Yes.
Is the key difference with the one on the left just that there are 2 rods, or is it also where the wires are connected to the
They're in
rods?
series with one another.
There's equations for resistors in series and parallel. They're quite simple, like 1 over R1 plus, you know. Yeah.
So this is how I do it. And I don't separate them by 6 feet. I think the max I put is 2 feet. And then I bond the top of the ground rods together to the center ground rod this way. And then in the dirt, while you don't realize it, is the connection going between the 3 rods all together at the bottom.
How long do you make those rods?
They're 8 feet. They're standard 8-foot rods.
Now,
How do you
since the top foot of soil is much more conductive, is there any usefulness to making more 4-foot rods?
No, if you're going to do anything, if you're interested in that just particular characteristic, then drive the ground rods at a 30-degree angle. Give more
see.
dirt.
Okay.
Okay.
Would this be better than pounding them in on top of each other?
It depends on the ground, the soil type, the property. You know, if you have bedrock, which is, you know, 6 feet down, this is the only way you're going to get around it. You're not going to be able to drive a ground rod through bedrock. I mean, forget it.
Yeah.
Okay. Now, just so happened, this one house that we did this up in Rochester, New York area, you know, right there on the waterfront, you know, of the lake, you know, it's all sand. It was easy. Okay. But if you have bedrock like they do in Pennsylvania, I found out real quick, you can't drive a ground rod 8 feet down. It's impossible. So you have to put it at an angle.
Would it be preferred if you could do it?
It would be preferred if you could drive them straight down, yes.
And how do you get past the code in the middle one where they say if you're going to do multiple ones, they need to be at least 6 feet apart?
Hey, the code doesn't specify 2 ground rods. Go look in the book. You can read till you're blue in the face. You'll find no reference to using 2 ground rods in parallel or in series rather. There will be no diagram in the NEC code book that talks about this arrangement. None.
As long as you have 2.
No, there isn't even a requirement for 2. It says 1 ground point.
Oh. And Bill, sorry for the, I missed the afternoon. What is the phenomenon that you're avoiding when you do the right?
You're
hand?
avoiding this yo-yo effect where this resistance at any moment in time is different than this resistance at any moment in time. And so by the way this is wired, right, in series, the current flow is going to go to this rod for a moment, and then it's go to this rod for a moment, and then this rod for a moment, and this rod for a moment, and keep going back and forth and back and forth.
But thank you. What I meant was, what is the phenomenon in the house for the EHS person that happens as a result of that? What do they experience, and how does it manifest?
They experience a feeling of high pressure It's commonly what I find. And when I come in somebody's house with this kind of technique, they feel a lot of pressure and they have a lot of stress. And they don't feel normal. They feel much better going outside the house than inside the house.
Well, all right, thank you. And what is the phenomenon going on in the house that causes the feeling of pressure?
The ground system is now become the path, okay, for dirty electricity frequencies to be, so to speak, sunk. They call it sinking the RF, okay, to a non-conductive surface. So
are you saying that this is due to the devices that they have running in the house?
Yeah, or the neighbors, or more likely the neighbors and the grid itself.
Okay, so it's incoming DE from other people.
Yeah, or the grid.
Right.
There's lots of stuff going on. As you saw yesterday in our little demo, you know, who would have thought the ground wire had frequencies on it?
Well, if you have a Fluke 289, you can see those frequencies.
Okay, so, but most of us building biologists have no idea there's frequencies on the ground. Right.
So Bill, just to put this to bed on the mechanics, you're not going to put 2, you're going to put 3.
Yes,
rods.
I always work in odd numbers.
Okay.
So
and
if I don't get enough resistance here, then I'll make a circle here, another rod here, another rod here. Then I'll string these together. Okay.
Okay, well, Bill, I have one question. You know, I kind of understand your idea of putting them 2 feet apart to make a rectifier bridge, but wouldn't it be better if they were 6 feet apart and are often virgin soil? More of this?
I can't hear you. There's somebody's dog barking. I couldn't hear what you said, Eric.
Okay, so I see that if you put the rods too close together, the soil gets saturated. So once again, why are you putting the rods only 2 feet apart rather than 6 feet apart where they're all in so-called virgin?
Okay, because I'm trying to make the equivalent, without doing it, a ground plane, which has a lot of conductivity surface area. That's why I'm doing what I'm doing.
Oh, I see.
Like at the TV station.
Yep.
Oh, I see.
I learned all this stuff, God knows, 30 years ago. So,
in that case, would it be okay if they're not actually in a line, but instead like in a pentagon kind of formation?
I actually have a little diagram we'll talk about later on. There's a method called a triangle, where you make a triangle, so to speak. That works also. So you have ground rod here, okay, and then you have a ground rod here, okay, and then you have a ground rod here, and this is wired to that, okay, and then all these connect this way. Then this wire runs to the house.
And that middle thing is not a rod. It's just a connection
rod.
point.
It's a rod.
Well, you don't have 4 rods. You have 3 rods plus a connection point in the middle.
Correct. Yeah.
That circle in the middle is a connection
Yeah,
point.
this does work.
Is that a better way to utilize 3 rods than all in a linear row?
Well, I'll tell you up front, under no circumstances will I make a ground system that is in series.
Yeah, okay.
Okay, end of story. I mean, this whole concept is crap.
I think what Eric's saying though is instead of the 3 rods being lined up in a line, your triangle shape is preferable.
And I have done some of these triangles. I don't find a difference tremendously with 3 rods versus the triangle. But when I can't get enough resistance with the triangle, what do?
Start putting wings on it.
Yeah, that's the problem. So you are dealing in unknown territory when you're at a customer's home and you don't know the dirt that well, you know, and you're not living there. So, you know, you're visiting, right? So if you go do this and you still wind up with like, you know, more than 20 ohms, we're screwed. You just dug all these or driven all these ground rods and didn't get the result you wanted. I
Can you-
guarantee you, you do this technique, you will get to the end result you're looking for.
And
Which is
it looks like the top chart, you can put it up against the wall, but you put the triangle thing and that's going to be away from the wall and people can trip on it.
No, it's buried. Once you drive this stuff in the dirt, no one even knows it's there.
So-
All my things I've done here basically are buried deep in the dirt and they just basically can't see it. Can't trip over it.
If
Bill,
you-
I have two questions. The triangle looks like there are 4 rods, and I thought it's supposed to be an
That is correct.
odd number.
That
And
is-
then it,
No, that middle circle is not a rod.
Yes, it is.
Oh, you have 4 rods there?
It's
Bill?
4 rods.
Oh,
Okay, so that is another method to do. I've only done it 3 times, and the 2 times it worked fine. The 3rd time, I wound up with more ohms resistance than I wanted. It didn't achieve my objective to get to 5 ohms or less. And so now, what do?
Can you,
it also doesn't look like it's in parallel. Looks like almost like it's not quite, but like in
No,
series.
they're in parallel. You wind up with a parallel path, the way this is wired.
So
Bill.
Bill, all the lines that you've drawn on your triangle formation, even the outside lines, are they all wires? So for example, the outside rods have
Yes,
3.
they're all wires. They're all number 6 gauge wire.
And in that situation, they're connected to the center rod at the rod, or is it important that they all connect on a wire, the grounding?
No, they
wire?
connect to the rod.
Okay,
Ew.
Bill, when you say number 6 gauge, I thought we were all wanted to use 1/0 braided.
Well, for the interconnecting, I use number 6 or number 4
Okay,
braided because you have to work with this stuff, right? I mean, 1/0 wire is great for the wire from the grounding system to the panel. Okay, but can interconnect and can be a lower gauge.
hey, Bill, how much of this material can we show to an electrician who we want to do this? Because he's gonna say, I'm on board with you, but I need to know exactly why.
Well, I need to write this up as a protocol for
Great, that
grounding
would be
system
really
as part of the
helpful.
other follow-on work from this class.
Thank you.
okay, so the interconnections, that's number 6 solid,
No, braided.
number 6 braided.
Yeah, it's something you can work with, right?
Bill, I have a question.
Yes.
Can you decrease the resistance or increase it, I guess, no, decrease, by pounding another 8-foot rod on the top of each one of these 3 outside rods?
Yes.
Would that solve your problem?
It might. It might. Here's
Okay.
here's the risk. You do all this effort and the resistance doesn't drop enough.
Yeah.
And I've had that happen to me.
So, but you would say you'd rather pound, if you could, you would pound them on top of each other and make it deeper into the ground?
No, I don't say that. If
Oh.
you're limited by yard space, you have no choice but to drive a ground rod on top of the other.
Okay.
Okay.
Okay, Bill, what about the north side of the house versus the south side of the house, or inside the drip line versus outside the drip line? How much importance does that make?
I don't know if it makes that much difference.
You know, here in California, the south side of the house can be, dead dry, several feet down on the sunny side of the house. And on the north side, it'll be more moisture in it.
If you have the ability to determine which side of the house has more moisture, I would go there. But it also depends on where is the service entrance and
Right,
where's the
yeah.
primary ground rod. Right? That also
Yeah.
has an impact of your decision how you're gonna.
Oh,
actually
it's
do it.
not like back in the Midwest where you get rainstorms all summer. It's a desert out here all summer, basically.
Yeah. So I don't know, but it depends on the electrical service entrance and where it's at. And you don't want to string a really long 1/0 ground wire, for 50 feet if you can avoid it.
So the other
So are
day you
you saying
mentioned that
keep the ground wire as short as possible?
Yeah, always try to make the ground path as short as possible. Yes.
the other day you mentioned that, I think you said you saw the Stetzer units dropped from 150 to 50 or 60 by just increasing the grounding rods. Have you found that that there's a basic formula like 50% reduction?
No, there's so many variables associated with this. The ground soil type, the grounding system, what you've done to change it. You know, that's all. It's all. There's a lot of variables involved here. So I have gone to some where I put 1-aught wire in and it only made 25% improvement in GS units. I've gone to other homes where we did this and we fixed the problem completely. So
Wow.
There's a lot of variables to this. You're dealing in this in the field where soil conditions and the wiring system and how the customer's panel is wired, all this has an impact.
Well, what's your definition of fixed it completely, Bill? From what to what?
Pardon me, I can't hear what's going on.
Oh, what's your definition of fixed it completely? From what number to what number?
I'm sorry, I got interrupted. Apologize. Go ahead, say again, Orm.
Sure, no problem. What's your definition of, well, when you just said you fixed it completely, what's the starting number and what was the ending number?
I think around 180 GS units.
Down to?
About 55 or 60, somewhere in that range.
Measuring all over the house.
Yeah, measuring multiple outlets, yeah.
Yeah,
No
and
kidding.
also, Bill, if you had a chance to look at the scope, did it clear up more of the high frequency or the low frequency stuff?
It cleared a lot of the lower frequency stuff.
You mean like below 10 kilohertz?
Between 3 and 12.
Oh, okay. So that's the stuff that parallel capacitive filters really don't touch.
Exactly.
Oh.
So that is good news.
Yeah.
Just by increasing the ground or decreasing the ground resistance.
Correct.
Huh.
Hey, Bill, you mentioned that I thought yesterday that you need the rods accessible, or at least one, so you can kind of check it and take it apart.
Yeah, just one rod. I don't have to have all these rods. Just so I can get to the grid. If I can't get to the, here's the problem, right? We start going to the houses, right? And then they got the ground rod buried. You can't see it, right? So now you may have to, if you got a big problem here, you may have to excavate and find a damn ground rod.
Right.
Okay. So you get a pigtail lead on it so you can measure it.
Okay, so just leaving that access to one's enough.
Yes, correct.
Okay, thank you.
So Bill, this is a situation where you're going to a house and you see everywhere it's about 180, 200, you see it all the time or higher. And we can't, it is due to other people's DE producing devices if your client has a minimum of them, and they don't have a lot of dimmers or the dimmers are not on, but you're measuring this background ambient level that's in the 150, 200, 250, 300 range. You're saying that it's not just the stuff coming in from neighbors. You can actually drop that a substantial amount by just increasing the ground conductivity.
Correct.
That's amazing.
Okay, so that said, that pretty much determines that the DE is on the wire, not on the ground. So it's not coming into the house through the ground rod like some people misbelieve. It's on the common neutral.
It's on the neutral. It's coming from the neutral. That's where all the DE, from all DE generating devices, routes, it's noise. It puts it on the neutral there.
But you're shunting it to the ground of the client's house you're in by doing this.
Yes.
So it doesn't get into the house.
Well, it evacuates the house as opposed to building up inside the house.
Any idea what the contribution of the smart meter is to the DE?
Yeah, that's a long story.
Depends on the smart meter.
We could be here an hour and a half.
Okay, let me just ask you one detail. In your very first example with the 5 ground rods in a line, it is important to connect them together at the grounding wire.
Yeah, but this.
Whereas in the triangle, you're connecting them at the center rod.
Correct.
Okay.
Yeah. So,
but
I thought I was onto something really hot and cool, and until I got to the third customer where it didn't work, and I said, "That's it." I spent, a full day pounding this thing in the dirt.
Oh, you do it yourself?
Sure, I don't have a problem putting in a ground system. Look, you don't have to be an electrician to put in a ground rod.
So Bill, just to clarify on your triangle below, every one of these wires is actually connected to the rod itself with a
Correct.
clamp.
Correct, with a clamp, just like we showed yesterday.
So that's different than your upper picture.
No, those are all still clamps, okay? So you didn't realize this. That's still a clamp. This is a mechanical clamp that you buy at the hardware store, okay?
Okay. And one last thing about pounding them into the earth, one on top of the other. You don't connect these rods, you just pound it in there and the earth itself makes the connection between the two rods actually.
No, there's a metal collar, like a tube, a very heavy duty tube that goes on top of the existing ground rod. And it has kind of a stop collar in it, okay? Okay, so it doesn't go all the way through like a tube does. It's kind of a stop collar. That goes on top of the ground rod. Then you take, in my testing, I basically take a short ground rod and use that to kind of drive the first ground rod in a little bit to get to where I want to put the other one. Because, you know, if you've tried driving ground rods, you're going to find out real quick you need a 10-foot ladder.
Yeah.
Okay, not an 8-foot ladder. Okay, because you can't get the hammer over your head to get the hammer thing in. So
I've seen this tube, Bill, that this collar that fits over and then you can pound it down that way. It's a very heavy collar.
Okay, I got so much junk in my truck right now. I'm not hauling that stupid thing around to be used once a month. Okay.
Hey, Bill,
Yeah.
can you clarify where this is in relationship to the service panel? We want it close to the service panel?
My recommendation is that the wire running from this grounding system to your service panel should be as short as you can make it.
Sure. And if, because of rock or whatnot, you can't drive it, can it go in a crawl space underneath the house?
At an angle.
Only at an angle?
Because you can't get your hammer over the top. I mean, if your crawl space is only, maybe some crawl spaces are only 2 feet deep. Some are.
Well, no, I have that situation. That's why I'm asking.
But you have to drive it at an angle. There's no way to drive overhead.
You drive from outside the opening to the crawl space, Cheryl.
No, it's fine. I have that situation. That was the only reason why I was asking.
You could.
Somebody did put it in.
My suggestion would be drive it at an angle. Okay. That's my suggestion. Okay.
Hey, Bill, what happens if you're starting with a ground plate? Can you just add rods or you have to take the plate out?
What do you mean a plate?
Like they're using like plates now, grounding plates instead of rods?
Those are superior. I think if I could get grounding plates and afford them, I'd use those, but I can't.
So, Bill.
So would you ever use more than one?
One grounding plate. Yeah, that's all you need.
Okay.
Bill, what about the idea of getting a ditch witch and making a trench 4 feet deep and maybe 6 to 10 feet wide and just putting a sheet of copper in there? Would that be superior to these rods?
Absolutely.
Have you tried anything like that ever?
Yes, I have.
How thick would it have to be, the copper?
It's typically 1/8-inch thick copper.
Oh, that thick?
Yeah, you have to be able to weld multiple sheets together if you need a big ground plate. There's a calculation for this, but
how about rollable sheet copper?
Well, that's no problem. I mean, but you can't weld multiple sheets together. That kind of copper sheet.
Yeah, but like 10 feet of copper sheet for 3 feet wide or so.
Yeah, and rivet it together with a grounding conductor, and you're off to the races.
Okay.
So
Bill, just to share this, this is the, I don't know if you could see. No, you can't see because
I can see. Yeah, I can see it.
Okay, so here's the coupling.
Yeah.
That you're talking about. Just to share this, so I had 900 ohms with one rod. And just for testing purposes, I added 8 10-foot rod. I went down 80 feet and only changed from 900 to like 700 ohms. So just to share that for some ground, as you point out, going down deeper doesn't necessarily solve the problem.
Yeah, the first 2 feet of dirt is most conductive.
Yeah, okay, with that said, Bill, why not just cut your ground rods in half and make them 4 feet then and be in the sweet spot of soil more often?
Because there is some specifications for grounding rods to be 8 feet long. I don't know where I found it, but I found it. It is a kind of a standard. The ground rods must be 8 feet long.
I see.
That's why.
So Bill, I'm really fascinated by this concept of soil conductivity from one part of the country to another, depending on moisture. So for those of us who are in California, Eric and Cheryl and Peter and I, we just have drier soils here. Are we going to have higher DE levels in our clients' houses, in all of our houses, because we don't have this shunting capacity? And B, if we were to increase these rods, would we have less of an improvement than you do in Michigan, where it rains a lot more often?
If you were to, in my opinion, okay, and I don't do a lot of digging in California to find out what's going on, okay, but I will tell you, because every morning there is dew, even in California. Correct?
Yep.
So
Yeah,
where does
well,
that moisture will be absorbed in the first layers of soil? So
Right.
if you drive 8 foot down, there's not going to be very much conductivity 8 feet down, but there will be in the first 2 feet.
So Peter and Eric, when you travel, do you notice a difference in DE levels in houses where you are at home versus when you travel to more moist areas back east or in the Midwest?
I have no experience with it.
Huh. I haven't paid attention, so anyway, I'm just, or those of you from other parts of the country who've come here or go to the Southwest or do a desert area, do we notice a difference? Is that something that Dave Stetzer has talked about and others, Sam Milliman, in terms of different parts of the country with different general DE levels noted in houses? Is that something that Bill, you or anybody else has?
I don't
But
think
I
the
mean,
soil's
the
determining
levels
factor.
have so many variables in there, then I would rather go with the ohms on the rod as a comparison.
Right.
Huh. Okay.
Yeah, could there be a bigger research project? Yeah, I don't have time for it.
Just curious if that's a general observation people have made.
All right, we're getting off in the weeds here. We need to get back on track if you don't mind.
All right.
Okay. So I thought I'd share with you kind of the grounding schema. For that client in Pennsylvania, we added 7 rods, I think.
So Bill, I'm confused in like Pennsylvania, if it's so rocky, why are they not using grounding plates? Because you would use them in areas where you can't drive rods the 8 feet or use 8-foot rods.
This customer had already spent $14,000 digging a great big hole with a big reconstruction project as a result. They were not ready to entertain digging another big hole.
Okay, but it's just not commonly used there in the rocky area?
No, copper sheet is expensive, okay? So this whole system with all these rods and all the wires and everything, the total cost was less than $300.
Okay.
That copper sheet would cost thousands.
Okay, I just know where I am. We use plates is kind of the way we go because of the rocky.
Yeah, if I had to pick between a plate or a rod, I'd use a plate.
Okay, so these rods nowadays, of course, are just steel rods flashed with copper.
Yep, that's all you need.
What?
That's all you need.
That's all you need. Okay.
Because you can't drive
your
pure
question
copper.
Copper will bend over.
Too soft.
Oren, your question regarding the moisture level of the soil. Bill mentioned something yesterday, which also came to my mind, is you can just water your ground rod. Take some water with some salt and then, keep watering it like you would do your plants. You should have much better.
Put your sprinkler system on.
Or I understand in Texas and Oklahoma, they put earth rods under where the drip hose is from the air conditioner in the attic.
That's a good idea. It's a good idea. All right, listen, guys, we're off in the weeds. I'm going to get us back on track.
Okay, but Bill, your first step would be to increase the thickness of the grounding conductor. You would remeasure earth resistance, then improve the grounding system.
Yep, correct.
With more rods. Okay.
All right, so let's get back on track. Did you get those photos to me?
Yeah, it took a while, yeah.
Give me a second.
Should be 2.5.
How much are the grounding plates? I think someone said they use them often in their area.
For
Are they
$40
more-
Canada.
How much?
And she, Anson.
$40.
British Columbia.
That's so bad.
Yeah, they're not very expensive.
Great.
So you have 2 pictures here.
On the second one, yeah.
Okay, all right, then thank you. So I'm going to share some modifications we made this morning to the ground antenna. Can you see the diagram?
See a picture.
Picture, I apologize.
Yeah.
Now I'm going to expand it. You notice, see that right there?
Oh, yeah.
So we got some really inexpensive 18 gauge bare copper wire from Home Depot. That could cost me like $13 for a roll of 100 feet of it. Okay. You guys, this stuff is cheap. So this is how I make a ground antenna, and I'll go through the formula for this. So when I use the picoscope, I look to see what frequencies are on the ground antenna, the pipe, okay, before I put the antenna in. And just to see what kind of frequencies are there. And so then I'll add some antenna wires just wrapped around that screw. These screws are, I think, a foot apart, these screws. And so there's 2 feet between here and here, 2 feet between there and there. Okay, but I could add more. And it's a number 6 stainless steel screw. You just drill an 1/8 inch hole, put in the screw, it goes in easy. And so you can wrap this, you don't need any connectors, okay? So let me I have a little demo of this, hold on.
Like a big TV, rooftop TV antenna laid on the ground.
Yeah, you're right, Orem.
All right.
We're showing our age.
Yeah, so
True.
so this is kind of a demonstration of what it looks like. So this is now in the yard, okay?
Mm-hmm.
So we just randomly took some wires. We didn't really do the research on this, but we should have, but it shows you kind of what it looks like. So when you bury this pipe, okay, you get what they call landscape stakes. The landscape stake is a U-shaped stake. You buy it at the Home Depot or Lowe's, wherever. They're about 2 feet deep, 2 feet long, with a square. It's a rectangle, so it's got a square head. Or you can use a nail if you want to use a long nail or a long screw. Okay, I don't recommend that, but you can use landscape stakes and tie it to the end of the wire, pound it in the dirt, make it tight with the pipe. Okay, and then once you're going to bury the pipe, okay, about a foot down, cover it up with dirt, and then tighten those strings of these wires here, left and right, using a landscape stake as a lever to kind of make it tight. And then that is now going to hug the grass. Okay, you don't bury these wires here left and right. You only bury the center pipe. Okay, and so by doing that, then you tighten these wires and put the landscape stake in, drive it hard. 6 months from now, you'll never see the wires or the landscape stake. You'll maybe see the dirt kind of disturbed for where the pipe went in the dirt. Okay, but this thing has disappeared in the yard.
Bill, is there a reason why you can't just wrap that copper line around the copper pipe instead of using a screw?
You need some mechanical thing that's going to be firm. That's
okay.
Wrapped around the pipe. It will tend to be loosened.
Okay. And what is the
Someone
purpose?
mechanically connected.
And what is the purpose of this? Why are we using this?
I'll explain here in a minute.
Okay.
Okay. But anyway, so that's what the ground antenna looks like. Okay. A piece of copper pipe with a screw, wrap a very thin 16 gauge bare copper wire from Home Depot. Okay. And just string them out. I'm going to show you how to do the actual calculations on this. Okay.
Sorry, I missed your response to Cheryl's question. What's the purpose?
The purpose of what?
Of making this. Why would we do this?
Because now you saw the frequencies on the grounding system. Remember yesterday we still had frequencies there?
Yes.
Okay. So if you know the frequencies, you can make these wires exactly the right length to attenuate those frequencies so that the amplitude of those frequencies on the grounding system can be muted to be lower.
Okay, so Bill, are you making a transmitting antenna, ground antenna, or something that's receiving signals from the ground here?
It's actually, it's a combination of both. It's a way to attenuate a signal is what we're doing, okay? It's not a transmitter, okay? We're attenuating signal strength. That's what we're doing. All right, does that answer your question?
For now.
Like at it, but
Bill, knowing the frequency from the picoscope, how do you figure out what the length
We're
of
gonna
the
do
wire?
that right now. I sent you the files. Okay, let me show, this is kind of what that little thing looks like. See that? There's the wire, there's the copper pipe. I used the screw with 2 connectors because I had to in order to demonstrate this. But I would not even put those connectors on it. I just use a screw. You wrap it around the screw, tighten the screw down, you're done. See that? Very simple. I happen to use 3/4 inch pipe in the yard because I'm moving this thing around the house all the time, and you know, if I used 1/2 inch, it'd bend around and maybe dent it. I don't know. Just for convenience, okay? 1/2 inch pipe is plenty adequate for what you're trying to do. So this is 1/2 inch pipe. Okay, that'll work too. You don't have to spend a fortune on this stuff. Okay. So that's that picture. Now let me show you in the files. All right, find it here. We're about to take a break here. Give me a second.
So in other words, instead of being a professional piano tuner, you may end up being a professional ground antenna tuner.
Correct.
And you don't want to put this on a lawn that needs to be mowed.
No, you can mow, yeah, within a week or 2, you can mow right over the top of this, no problem. Do it all the time.
Just pound it down below the grass blade.
Correct.
What are those wires connected to on the pipe?
They're just connected to that screw. They wrap around that screw, tighten the screw down. Now it's mechanically connected to the pipe.
But they're not connected on the other side of the wire?
No, the other side is just goes onto a landscape stake, which is pounded in the dirt.
Okay, so every wire should be connected to a landscape stake.
Correct. Correct.
So Bill, do you do the ground antenna in addition to rods? Or is that just something?
It depends. It depends on, here's the real test is then you go look at body voltage and the customer and look at, you know, bed maps and all that kind of stuff and say, do I need to go further? Yes or no? I don't know. It's definitely, there's some bit of experimentation that goes on when you're doing this. I mean, this is not simple. Okay. All right, so I'm going to project, you have this right here, the ground antenna formula, okay? So I have, I'll show you how I did this. All right, so, okay. Let me project that. Okay. Okay. I'm going to stop the recording right now and then restart it.